few months ago, fellow YouTuber Tommy Houghton and I decided to challenge each other to build the fastest Ender 3 we could with a budget of just $100 US. The point of the challenge was to see just how good you can make an Ender 3 without spending a lot of money. In today's video, I'll share my strategy and some of the upgrades that I decided on, and ultimately what led to my downfall. Spoiler alert. Okay, so this is the machine that I'm working with. It's a slightly upgraded Ender 3 Pro that I found on Facebook Marketplace for 80 bucks. The cost of the original printer doesn't count towards the budget though, only the upgrades. At the current exchange rate, $100 US is just over 145 Canadian dollars, so that's going to be my budget for upgrades. The printer I found has quite a few upgrades installed already. It has a 32-bit mainboard, a micro Swiss hotend, a glass bed, a new toolhead, and some other printed upgrades. For the purposes of this challenge, I won't be allowed to use any of these upgraded parts. For the board, I'm going to be swapping to an old Creality V1.1.4 board that came from my old Ender 5, since it's essentially the same as the stock Ender 3 board. All of the other upgrades will be replaced with something else, but we'll cross that bridge when we get to it. First things first, I'm going to disassemble the existing printer and talk about my strategy for the upgrades. With a limited budget, we have to prioritize all of the potential upgrades we could install and only use the best of the best. In my opinion, the three areas that need the most help are the firmware, the toolhead, and the Y-axis. Marlin on the stock 8-bit board would be very, very limiting, and using Clipper will allow for things like input shaping and more advanced kinematics as long as I'm using something like Calico. Clipper is also relatively inexpensive, with a Raspberry Pi Zero 2W selling for as little as $21.50. Let's make that our first upgrade. Since the Ender 3 is a bed slinger, we know it's going to be limited by the performance of the Y-axis. I'm not going to be taking any chances with the stock motion system. The most obvious upgrade though is the toolhead. The stock Ender 3 is bottlenecked by its terrible extruder and its lackluster hotend. A nice, rigid toolhead with an upgraded hotend and a direct drive extruder would do wonders for the performance of the machine. But it's going to be hard to do all of that for cheap. I shopped around on AliExpress, looking for good deals on all the parts I could use. I found clone bamboo hotends being sold for $8.02 and a BMG kit for $6.62. I also managed to snag a Pancake NEMA 14 for only $11.89. In total, that's $48.03 spent so far, about a third of our total budget. I think now is a good time to mention that I'm not going to be directly counting the cost of hardware like screws and nuts. Instead, I'm going to aim to have a bit of slack in the budget, and we'll call whatever extra money I have left the hardware expense. For complete transparency, I'm doing this because I'm lazy and I don't want to count everything. In order to print fast, you need to make sure you have plenty of part cooling, so I knew that I'd be looking for dual 5015 fans. I decided to play it a little bit risky and order some 12-volt GDS time fans on Amazon, with the intention of running them on 24 volts for extra performance. While this sounds like a surefire way to kill your fans, many people seem to run overvolted GDS times without issue, so I figured I'd take a chance. It was $15 for those two fans. Now I just needed to find a toolhead that would support a bamboo hotend, a BMG-based extruder, and dual 5015s. There are lots of options for toolheads on Thingiverse and printables, but some of them are questionable. In the end, I think the best option for a toolhead is Stiffy by Churls. He has a YouTube video showing it printing a quality benchy in 16 minutes, so it evidently performs quite well. The toolhead is designed for the stock Ender 3 hotend, but with a little bit of modification, I managed to squeeze in a bamboo hotend. For the extruder, I opted for the Sherpa Mini, printed in bright yellow Polymaker ASA. For the hotend fan, I swapped the 12-volt Noctua on the old machine for a normal 24-volt 4010 like the stock printer uses. While it doesn't directly increase the performance of the printer, I'm sure we can all agree that auto bed leveling is very nice to have. I picked up a 3D Touch for $11.18 and mounted it on the front of the toolhead. Since the bamboo hotend sat a little bit lower than the stock Ender 3 one, I needed to get a little creative with the spacing. Heat sets worked surprisingly well for this. Before we continue, I would like to thank the sponsor of today's video, PCBWay. Are you working on your next project? Whether you need high-quality PCBs, PCB assembly, 3D printing, laser cutting, or even CNC machining, PCBWay has you covered with their affordable and reliable manufacturing services for hobbyists and professionals alike. Whether you just need one part or dozens, PCBWay can make it happen. Of course, using PCBWay's services for a challenge like this would be cheating, but I will be trying out their laser cutting and CNC machining services for a later project. If you want top tier quality and quick production times, be sure to check out PCBWay with my link in the description. And thanks again to PCBWay for supporting the channel. Everything here looks pretty good, and has been pretty easy on the budget as well. However, there was one thing I was really starting to worry about. You see, on Churl's GitHub, he says that you should use at least a 60-watt heater cartridge in your hot end, otherwise it could get overwhelmed by the part cooling. This is an issue for me, since not only is the stock bamboo heater only 48 watts, but it's a ceramic heater, so the wattage decreases as the hot end gets up to temperature. I couldn't find stats for the exact 48-watt bamboo heater, but here you can see a graph published by Fadis for the Rapido. By the time you're getting up to ABS temps, the power of the heater is effectively cut in half. If I was doing this challenge again, I think I would opt for a different hot end entirely. However, I did have a way to dramatically increase the power of the bamboo hot end. It's just a little sketchy. For $5.79 on AliExpress, I purchased a pack of 3 replacement heaters and thermistors. These heaters are 65 watts, a nice upgrade over the stock heater, but still not enough to cope with the part cooling of overvolted fans. The solution?
More power, baby!
Okay, so I'm not going to advise that anyone does this, right? But nothing is stopping you from wiring multiple heaters in parallel and slapping them all on your hot end. Here I'm using 2 65-watt heaters, one on the front and one on the back, for a total of 130 watts of power. You can still sort of put the silicone sock over everything, but I found that you needed to wrap a paperclip around the sock to keep it from falling down. That paperclip is going into that aforementioned hardware expense, by the way. Like I said, I don't necessarily recommend this approach, but it does get the job done. I think the Toolhead looks great, but we could use some cable sleeving to tidy everything up. I also needed to get some PTFE tube for the reverse Bowden, and I bought both of those from 3D Labtech for a total of $7.40. Of our original budget of $145.19, we have $57.79 remaining. Let's leave the Toolhead as is for now and focus on the y-axis with the remainder of our budget. Since the y-axis is obviously much heavier than the x-axis, I want to do whatever I can to reduce weight and add more power. Reducing weight is easy enough. I removed the old glass bed and the magnetic sheet under it, and I'll just print on a layer of Kapton tape instead, since it's cheaper than buying an actual build service. That roll of Kapton tape costs $4.30. We have 2 options for the motors: the stock Y motor or the old extruder motor. The stock motor has a pulley press fit on the end, so there isn't a whole lot we can do with it. We could remove the pulley, but we wouldn't be able to put it back on again. The extruder motor, on the other hand, is a little bit more interesting. Not only is it a larger motor that most likely has more torque, it also has a longer shaft. In fact, the shaft is just long enough to fit a 9mm pulley with full double shear support. You see where I'm going with this? I adapted the motor mounts themselves from this model on LH's printables page. I really like the design of these support feet here, and I'll show you why. Take a look at Tommy's Ender 3 in his latest video about it. You can see here that when the bed is moving fast, the entire Y extrusion is tilting. These feet here should support the Y-axis during fast print moves and stop it from rocking back and forth. The only problem is that LH's motor mounts don't have any double shear support, so I had to go and do that myself. It took a couple of revisions to get just right, but now we're ready to go. This bolts on exactly where the stock motor mount goes, but it does need longer M5 screws to fit. I hope I just have it on backwards. Please tell me it's just on backwards. Thank God. Originally, I thought I made a mistake, but it turns out I just had the bed carriage on backwards. That could have been disastrous. For the Y-axis, I bought 9mm pulleys, 9mm tooth idlers, and 2 meters of 9mm belt. In total, that ended up being another $32.34. Not bad. At this point, I had about 1 week left until the video needed to be done, and unfortunately, I wouldn't have time on the weekend to work on the printer. I decided that once I got back to it on Monday, I would install Klipper and start testing. After all, I hadn't actually stopped to make sure anything worked just yet. Unfortunately for me, Klipper would ultimately be my downfall. Let me explain. No matter what I tried, I could not connect to the Pi Zero. I spent all my free time on Monday troubleshooting this issue, only to eventually give up and swap to a different Klipper host entirely. Okay, so in the end, I ended up just replacing the Pi Zero with another Pi I had laying around. I say laying around, I actually stole it from the Simple Core, but that's a different deal. This one actually worked. I was able to get Klipper on it. no problem. I can connect to mainsail through my laptop, all that good stuff. Works great. I don't think anything's wrong with the other one. I'm sure I could get it to work if I have more time, but at this point when I'm recording this, it is already Tuesday night. I don't even have a working printer, let alone a video with the script and all that stuff, so I'm really running out of time. So we're going with that. In a controversial decision, I'm going to say this doesn't count as an upgrade because it isn't giving me any more functionality. It's just a Clipper host. A Clipper host is a Clipper host. I understand at really high speeds, the extra clock speed of the CPU, could be a factor, but it's an Ender 3. However, with my luck, even though Clipper's working on here, the board is not playing nice. Again, I'm having issues. Fair warning, I've never flashed an 8-bit board before with Clipper. All of my Clipper machines have been either just bought outright, like I bought a used thing, or scratch built. So I've never had to actually try this on an 8-bit board, and so far it's not working. If I can't get this to work within an hour, because it's already 7 p.m., if I can't get this to work within the next hour, I'm just going to go to the old spares bin, grab an SKR Mini, which I know works. I think I actually ran Phoenix, maybe not off this exact one, but same kind of board. I'm going to grab that. I'm going to eat the extra cost of it, which is going to put me over. It's going to cost points, whatever. And I'm going to put that in there, and that's going to be what we run. Because I'm confident I can actually get it to work on that. And then, if all that stuff works, then we have a chance. Because we will be able to at least see if the Toolhead works. Mind you, I have no idea if everything here is going to work. My heater setup is janky as hell. It might just break, explode, I don't know. But so far, I haven't even been able to try because of all these other issues. And then if all that stuff works, we can get the bet on. Okay, here's your final update. So it's almost 10, as you can see. I just went down, I replaced the main board with the SKR2. I went and made the new firmware in Kua. I went, downloaded the file, put it on the SD card, flash it, all that kind of stuff. And I'm trying to get the MCU ID here, and it's still not finding it. So I'm going to try a new cable. The issue is just that those boards, and it's just those boards in particular, they use that mini USB, I think is the official name of it. Anyways, I don't have a lot of those. All my boards, my new ones are USB-C. Some of the other ones, the newer SKRs, they're all micro USB, but I don't have many of those cables. I could only find one. So I haven't been able to find a replacement cable to see if it isn't the cable. Tomorrow, when I get back from university, I will take a look, try to find that. If I can't find that, then I guess I'll grab another board, and one that has the micro USB. I think I have an SKR, I don't remember what it's even called, an SKR RRF. It's one of the ones that was made for RepRap firmware. I think those have the micro USB, which I have more of those cables that I can try. Otherwise, at a certain point, I have to just throw in the towel or something, because this is getting ridiculous. But that's the plan. So I'll see you guys tomorrow, and hopefully we can get something sorted, because yeah, this sucks. Hello everybody. As you can see here, this is my Ender, but it's not exactly in a working state. So let's talk about this. Overall, things are actually going pretty well. I'm super happy with this Toolhead. I have a monstrosity of a hotend in there, held together with a paperclip, dual heaters running wired in parallel, all that good stuff. But in the end, what ruined me was unfortunately the firmware side of things. So finally, in a last-ditch attempt, I tried to pull out the old SKR Mini E3 RRF, which is actually what I ran on Phoenix for a while. Actually, the entirety that Phoenix was alive, but I still could not get it to work. I actually had different issues with all three boards. This time the issue was actually making the firmware file, as Kua kept getting stuck during the process. Possibly some sort of connection issue, but I'm not sure. In the end, I've spent about 5 days trying to get the stupid firmware to work, and I just can't. And at this point, I've kind of run out of time. So I'm bowing out. Tommy wins. Congratulations, Tommy. And it's unfortunate, but that's sort of how it goes with these sort of things. Especially true when you're working on a deadline. And poor Tommy's had his Ender finished for over a week now, and I'm just floundering around with all this stupid firmware stuff. So It is what it is. It's unfortunate, but sometimes that's how it goes. In general, I do think this idea has some pretty major promise. Just talking with Tommy and seeing his results on the stock motion system, I think all you really need is a nice tool head, and you can get some insane results with an ender. So I don't want to abandon this idea of like really budget conscious upgrades for old printers that a lot of people probably just have around collecting dust. But unfortunately, at least in the context of this competition, that's it for me. Well, there you have it, folks. It's definitely not the result I wanted, but sometimes that's just how it goes. Thank you so much for watching, and I'll see you guys in the next video. If you haven't already, make sure to watch Tommy's video so you can see the upgrades that he did and actually see a working printer at the end of the day. Alright,